All right, so starting the digestive system. Fun chapter. So there are a lot of structures that are involved with the digestive system. And what's very interesting is that, okay, our digestive system begins with the mouth. And the whole system is a system of hollow tubes, all the way to the end, at the rectum and the anus. And it's considered an open system. You have a series of sphincters throughout the digestive tract to kind of segment different areas that are, occurring, where different things are occurring within the digestive tract, but technically it is one long hollow tube, and we call it the alimentary canal. Okay, so here's an important thing to remember right off the bat, because I will ask a question about this. So something that is within the respiratory system, let's say I swallowed, I had one of those cinnamon sticks from Pizza Hut for lunch. Yeah, I know, it's super healthy. So my cinnamon stick is in my stomach, okay? Is that cinnamon stick really in my body? Is it inside me?
What do you consider you?
So this is a trick question. What?
What do you consider you?
Me, myself, my body. Am I not?
By your skin.
I'm sorry?
It's encapsulated by your skin.
Okay. I get what you're saying, Josh. Would you prefer Josh or Joshua? Because if I say Joshua, I'm going to say it silly. Joshua. Okay. So, yes, initially our first thought is, yes, it's in our body, right? But remember, the alimentary canal is a big hollow tube. It's open at both ends. Technically, it's not inside our body. It's only the food we eat. It's only inside our body once it's actually been absorbed through the intestines into the bloodstream. So it is kind of a tricky question, which is why I'm telling you now, so that you're prepared when you see a question like that on the exam, okay, is that it is not, something you've eaten is not truly inside your body until it has been absorbed. Otherwise, remembering that this whole thing, alimentary canal, is an open system. And so because it's an open system, that's why we have that little special rule, okay? It seems weird, I know, but that's the way it works. And so I'll tell you what I told this morning's class. And when I was in college, the professor who talked about this gave an analogy that I will never forget. And I pass it on to my students because I probably think you won't forget it either. So remembering that it's the alimentary canal all the way from your mouth all the way to the anus is an open tube. Okay, it has some sphincters, but it really is an open tube. And so the way he tried to illustrate this was, he told us, so it'd be like if you took some dental floss and you swallowed it, you held onto it in your mouth, but you swallowed it and it passed through your digestive system all the way out. Because it's an open system, then you could move it back and forth. You see what I'm saying? In reality, the discussion this morning was, that would hurt. And we're like, yes, of course it would. We wouldn't actually do that. But it's just an illustration of, it really is a hollow tube with sets of sphincters that kind of divide it up. Yes, Joshua?
You couldn't actually, it's not straight.
No, it's not straight. No, you couldn't actually. It would probably pull and hurt and not a good idea. Please don't try it. But his analogy, although it wouldn't work in reality, illustrates that it is a whole open tube. And I think he also was trying to shock and gross us out with the whole idea of flossing back and forth. So anyways, I never forgot that. So I'm going to write on here, just remembering the whole system, the tube, we call it our I may not spell this right. Okay, so alimentary canal. So it may be spelled wrong, but you know what I'm talking about. So the whole set of tubes from beginning to end. Okay, so we're going to talk about the functions of the digestive tract. Okay, and there is some stuff on the board. We'll talk about that in a moment. Okay, so the very first function is my favorite, which is ingestion, which is eating. I mean, come on, don't we like to eat? Food is good. Well, depends on where you go, but yeah, food is good. I love ingestion. I love eating. And so that means you're bringing food into your mouth, and then the second step is mastication. This is where you're chewing your food, and the process of chewing your food, we call that mechanical digestion because you're breaking the food up into smaller pieces. It's good to break it up into smaller pieces. First of all, it makes it easier to swallow, and then secondly, breaking it up into smaller pieces makes it easier for the digestive enzymes and the acids that are in your stomach to break down those smaller pieces. And when they're smaller pieces, they have a larger surface area, which might sound weird. Let's see if I can illustrate this. So if you had, let's say you ate a marshmallow, okay? Since this weekend's going to be nice, you know, I might be roasting marshmallows. So here's marshmallow, okay? So here's a marshmallow. If you chewed it, that's a really bad example. Let's say graham cracker. That's easier, okay? Just because marshmallows are hard to... Anyways, so we have a graham cracker. If you chew that graham cracker up, you're going to have all these little pieces, right? And it's probably going to start, you're adding saliva to it, and it's going to get all mushy and stuff. But by chewing it up, you make it in these small little pieces. So each little piece is tiny, and for its size, it has a large surface area for its size compared to a whole graham cracker. And so by breaking it up into smaller pieces, you have more surface area where the chemicals can reach it to break it up even more. Okay, so chewing your food, mastication is important. So mastication, just to remember, is mechanical digestion. Chemical digestion requires actual chemicals, and that most of chemical digestion, most of it starts in the stomach, okay, because you're using chemicals. But we break it up into smaller pieces before it gets there with our mouth, okay? So you've chewed your graham cracker up. It was delicious. Or let's say you actually put it together into a s'more, and it was delicious. And now you're going to swallow it, okay? So first of all, the term for swallowing is deglutition, okay? So you swallow that wonderful s'more. Now, that s'more has to travel down your esophagus to your stomach. Gravity's not going to be doing it. So how it travels is through peristalsis, okay? Peristalsis, and I did write this on the board. Peristalsis is, first of all, our whole alimentary canal is lined with smooth muscle, okay? So peristalsis itself, its function is to move food in one direction, okay? And yes, we capitalized this and mentioned the band this morning. I got lots of groans. It was fun. So peristalsis is in one direction. So if I swallow my s'more, it will basically, you have your esophagus, you know it's a hollow tube, lots of smooth muscle around it. You swallow that lovely, lovely s'more. And it's basically, peristalsis is like you're squeezing a Go-Gurt. Okay, so you have these circular contractions that go down the esophagus and squeeze what you ate down into your stomach. Okay, so it's like a go-gurt. I don't know how else to describe it. But so remembering that peristalsis moves in one direction. Okay? And another term that's helpful for you is a bolus. What's a bolus? Well, that is the wad of s'more that you've chewed up and you're just about to swallow. Okay, when you're chewing something, you don't really think about chewing and swallowing usually. But when you chew it up and it's about ready to swallow, your tongue helps form kind of a ball with that food, and that's called a bolus. And your tongue pushes it back to the back of your throat. It triggers the swallow reflex, and then you swallow it, and then the smooth muscle helps squeeze it down into your stomach. Okay? Once that food, that bolus, gets to the stomach and it mixes with those digestive enzymes, we then call it chyme. Okay? There is... So I know on here it says mass movements. I want to talk about mass movements last. So peristalsis is the first thing I wanted to mention. The second thing I wanted to mention was the mixing or segmental contractions, and that will be on the next slide. So segmental contractions. And this is for mixing. And this happens in your small intestines. And so it's your small intestines are hollow muscular tubes, smooth muscle. And so instead of propulsing and moving the chyme along the digestive tract, sometimes instead you have contractions that help mix the food even more in the small intestine, even helps break it up into smaller pieces than you had in your stomach, which makes it even easier for digestive enzymes to reach what's left that needs to be broken down. So a kind of the analogy I use for that is like a water balloon that's not completely full, so there's a little, you can squeeze it, you know what I'm talking about? So if you had it in both hands and you could squeeze the water back and forth, like swish, 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 you know what I'm talking about? Can you imagine what I'm talking about? That's kind of the motion that's occurring when you have this mixing or segmental contractions occurring in your small intestines. It's there to mix the food with the digestive enzymes back and forth, squeeze, 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 back and forth. It's not moving it in any particular direction. Its job is just mixing it up, okay? So that's all it does. So we want to make sure we remember the difference between peristalsis. Peristalsis, when we talk about it, we're talking about it moving food, moving chyme. It's moving things within your alimentary canal in one direction, okay? Mixing, you are using the smooth muscle contractions. It's peristalsis in a way, but it's not moving it anywhere. So we call it mixing or segmental contractions, and it occurs where? Where does it happen? Thank you. Yes, happens in your small intestine, because those notes aren't on here yet. Okay? And then lastly is the mass movements. Mass movements occur in the large intestine, and typically they can be triggered if you eat a big meal. We'll talk later in the chapter about how it can trigger these mass movements and cause whatever you have within the large intestine, peristalsis, moving that material around and down to the rectum, and people typically will have to go to the bathroom maybe 20 or 30 minutes after they've eaten a meal. Have you ever met anybody who's like that, like regular, like a clock? Okay, I totally embarrass my son all the time. He would kill me. But my son's like that. He eats a big meal. Well, not too long before he's back in the bathroom clogging the toilet. Not even kidding, this 8-year-old boy. Like, what? Anyways, so these mass movements, it's triggered. Basically, you eat a big meal, you need to make room for the new food. And so it's a obviously you're not consciously thinking about it, but it's part of a chemical regulation cycle that we'll talk about. And so you eat a big meal, it triggers your body, it triggers these mass movements to get, hopefully, your large intestine more emptied out to make room for the new stuff that will be coming. Yes, sir. Joshua, sorry.
In the case of mass movement, would your body not be getting all the nutrients that it could be from that food?
No, it wouldn't necessarily mean that. This is, mass movement means whatever is already within the large intestine. So it doesn't mean, like, a mass movement doesn't mean that you're going to have, like, diarrhea or you're not getting all the nutrients you need. It's once it's already in the large intestine, it's mostly waste. What happens in the large intestine is you do reabsorb extra water. There are a lot of a lot of bacteria in there that is helpful for us. One of the things the bacteria within large intestine does is, well, there's two good things. Helps break down some of the food we can't break down. So we can get a small amount of nutrients, very small, but they produce vitamin K. And that's where we get it. The bacteria produce it within our large intestine. So there's a few really important things that are happening there, but mass movements, it's not mass movements within the small intestines, which would influence how much nutrients you're absorbing. It's just within the large intestine where you've already absorbed as much as you possibly can. Does that answer your question? Okay, that's a good question. Okay, so this is showing mixing, but we've already talked about mixing, the segmental contractions, that this is kind of squeezing the tube back and forth to mix the food that's in there. Well, not the food, it's called chyme when it's in the small intestine. To mix it up, break it down into smaller pieces, makes it easier for those enzymes to reach those particles, break them down so they're small enough to actually be absorbed into the bloodstream. And so, as a reminder, it only occurs in the small intestine. Okay? Continuing with functions, secretion. So there's different types of secretions that occur, and they all have really important functions. So the first one that's mentioned is mucus. So just to let you know, the whole alimentary canal is lined with a mucous membrane. Okay? So there's mucus in the whole alimentary canal. And it's good that it's there. It acts as a lubrication for food moving through. It's very helpful for when you do have mass movements, for example, in your large intestine. What would happen if you didn't have mucus in your large intestine? You wouldn't die, you wouldn't feel very good. It would be really hard to pass a stool. Constipation? Yeah, not fun. So mucus is important. So in this, just we're talking about the large intestine, it helps with lubrication, making things move along easier. It's important. And throughout the whole digestive tract, from the beginning to the end. Another really important function of mucus is within the stomach itself. The stomach is making very strong hydrochloric acid, and you have digestive enzymes. You don't want them actually breaking down the stomach wall, so we have a good layer of mucus within the stomach to help protect the tissue of the stomach. So it's acting as protection, helping to prevent those very caustic chemicals from actually reaching the stomach wall. Because if it did, then you would not feel good as well. Okay. Water is another secretion, or if you're drinking water when you're eating, that is also very helpful. And so, notice, so it makes food easier to digest and absorb. Now, this morning, I brought up Ellen White, and I was taught, although we didn't really follow it, that you're not supposed to drink fluids or drink water or anything when you're eating. I don't remember the whole reasoning behind it, but I think the idea was they thought that it would impede digestion, that it would dilute the digestive enzymes and such, but in actuality, it doesn't. Adding the water helps liquefy the food that we're eating and aids in digestion. We need that water. So it's just kind of interesting, certain ways you were raised and belief systems, and she was right about a lot of things. She totally was. But when we talk about water, we need water to help with digestion. Okay, bile. Okay, give me we'll finish this up really fast. Last slide. Bile is made by the liver. It's stored in the gallbladder, and it helps break down fat. So fatty foods that you eat. Enzymes, chemical digestion, you have that in your stomach. Almost done, guys. Also, you have one in the mouth too, and then you have a lot produced by the pancreas. So as we've already mentioned, there's a difference between mechanical and chemical digestion. We've already talked about that. Absorption. So here's that tricky question there. So remembering that food is not truly, quote, inside the body until it has been absorbed in, because that alimentary canal is a hollow tube. Last of all, last function, number 8, elimination, involving, your large intestine. So getting rid of your solid waste products. All right, we're done for today. Thank you very much. You guys have a wonderful